Hi everyone, welcome back to this channel. My name is AVABHRATA, SDM PU College, Manama. In the previous video or previous session, we were discussed about the P block elements. Under the P block elements, we had a discussion over 15th group elements. The 15th group elements contains nitrogen, phosphorus, arsenic, antimony, and bismuth. What are the properties of 15th group elements and the uses of the compounds of 15th group elements? These all things we have discussed in the previous session. In this session or in this video, we discussed about the oxo acids of the second element of the 15th group. That one is phosphorus. Okay. According to your old syllabus, there are a lot of things under phosphorus. Correct. So allotropies of phosphorus, compounds of phosphorus, phosphine, and other things. But according to the new syllabus of 2021 only, the compounds of phosphorus, phosphine, phosphorus trichloride, phosphorus pentachloride, these all things were deducted. Okay, so therefore there is no need of study of that compounds. If you are interested to know the things of phosphorus, you go through notes. Okay. Where you can study all the compounds of phosphorus and all things. It is possible. Okay. Let us move on to according to the syllabus, the oxo acids of phosphorus. Here, the only structure of oxo acids of phosphorus are important according to the new syllabus of 2021. Okay. Oxo acids of phosphorus. Oxo acids of phosphorus. Under phosphorus, the allotropies of phosphorus are white phosphorus, red phosphorus, and black phosphorus. The white and red phosphorus is mainly used in the manufacture of matchsticks. That things you already know, it's a general thing I think. Oxo acids of phosphorus. Oxo acid, what is the meaning of oxo acids? In the previous part of this topic, the nitrogen, oxo acids of nitrogen, the very important oxo acids of nitrogen is nitric acid. That part we were discussed in the last video. Right? Those who are not watch that video, please just go through the last video and come back to this session. Oxo acids. Oxo acids means the acid means contains hydrogen, correct? Hydrogen compounds mainly, and the oxygen and hydrogen compounds. Okay. The phosphorus contains oxygen and hydrogen elements in the compound. Then it is known as oxo acids. Under phosphorus, there are several oxo acids there. The reason of different oxo acids or the possibility of the formation of the different compound is only because of the oxidation state. Phosphorus has, again, it has the ability to show the multiple oxidation state as similar as that of the nitrogen. But when we compare the nitrogen and phosphorus, phosphorus has more capacity to show the multiple oxidation state. Hence, it shows a possible formation of the different oxo acids of phosphorus. Okay, let us discuss about the one by one. The first oxo acids of phosphorus is hypophosphorus. Hypophosphorus. The word hypo is because of the less number of oxygen compared to the hydrogen in the compound. Okay, the hypophosphorus formula is H3PO2. Lesser number of or the lesser concentration of the oxygen element in the compound. Hypo. Okay, lesser concentration of oxygen, higher concentration of hydrogen. Therefore, this word is used, and the reason of the suffix. Okay, the reason of prefix hypo is because of the ratio of hydrogen oxygen, and the rest OUS PIX is used. It is because of, again, it is according to the oxidation state of the phosphorus. If oxidation state of the phosphorus is less, then we use the suffix OUS, otherwise we use IC. Correct? Okay, so then what is the oxidation state of the phosphorus in this compound? What is the oxidation state of phosphorus in hypophosphorus acid? The oxidation state is calculated using the oxidation state of the other element. In the oxidation of the oxygen number shows -2. -2 into 2 is 4. -4 plus 3 become -1 and goes to the right side, then it becomes +1. Correct? In the oxidation state of the phosphorus in hypophosphorus is +1. Next, second compound. Okay, and then what is the structure of this one? The structure is very important. According to yourself, the structure is very important. Okay, the structure of hypophosphorus acid is, it's a phosphorus at the center of the central atom element and contains one oxygen with a double bond, one oxygen lost out, one OH, and others are hydrogen. If you know well about the hybridization possibility of the formation of the compounds from phosphorus, that states that, or that gives the conclusion is most of the phosphorus is in tetrahedral manner. Okay, because of that hybridization, sp3 hybridization is observed in the phosphorus mainly in all the compounds of phosphorus. Therefore, it's tetrahedral. That's why I am representing the compound, or they represent the structure in this way. Okay. Next, in the hypophosphorus acid, how many phosphorus oxygen bond is there, and how many phosphorus hydrogen bond is there? Okay, just count the number of phosphorus oxygen bond. There is a one bond. Okay, there is a one POH bond, and there are two phosphorus hydrogen bond. We have to represent in this manner. There are one bond and there are two bonds we observe. What is the reason of the study of the number of bonds between the phosphorus oxygen and phosphorus hydrogen? The reason is because of to identify the capacity of the reducing nature of the compounds. What is the capacity of reducing nature of this hypophosphorus acid? For that purpose, we need the number of phosphorus hydrogen bond and phosphorus oxygen bond. Okay? Then how to utilize the number of bonds to study the reducing capacity? If any compounds shows, or any compound has, or the oxoacids of phosphorus, the compound has more number of phosphorus hydrogen bond, then it has more reducing capacity. It has ability to reduce the any other compounds. Okay? In which manner it reduces? If, just observe, the bond cleavage of oxygen hydrogen bond is little difficult compared to the phosphorus hydrogen, easily used, and hydrogen reduce the other. Okay, as that in that manner it used as, or it has capacity, get the capacity of reducing nature. Okay, it has more reducing nature, more reducing capacity. Or you can say on the basis of phosphorus oxygen bond also, if the phosphorus oxygen bond is lesser number or phosphorus hydrogen bond is more number, then reducing property of that compound is more. Next, the second compound is orthophosphorus. Okay. What is the structure of orthophosphorus? Or what is the formula? Okay, the second compound, orthophosphorus. The ortho is opposite to that of hypo. Okay, ortho means number of hydrogen is, number of oxygen is more compared to the first compound. So it become H3PO3. H3PO3 is the second compound of oxoacids of phosphorus. Then what is the structure of this one? Structure is before that oxidation state. Oxidation state of orthophosphorus acid. A phosphorus in phosphorus acid is -2 into 3. Okay, -6. 3 goes out. It is +3. Oxidation state of phosphorus in orthophosphorus is +3. Then question arises, no? If the phosphorus has lower oxidation state, then we use OUS suffix. Then what happened in this case? +3 oxidation state, little bit higher than the +1. Although I am representing it as phosphorus, then what is the reason? The reason is the highest oxidation state of the phosphorus. Highest oxidation state of the phosphorus in the compound is +5. If phosphorus in any compound shows +5 or more than +5, then no, we use more than +5 is not possible. +5, then we use IC suffix for the compounds. Okay, because of that I am using OUS suffix in this compound. Okay, please remember these +1 and the +3 oxidation state. Next, what is the structure of the orthophosphorus acid? P, okay, as a center, phosphorus. Next, similarly, oxygen bonded to the phosphorus, okay, the double bond. Next, OH. Next, another OH. Next, hydrogen. Okay, here what happens? Number of oxygen phosphorus bond is increases. Number of phosphorus hydrogen bond, POH bond is number of hydrogen bond is 2. Number of PH bond is PH bond is 1. Because of that, reducing property is decreases. Reducing properties decreases. Okay. Then what is the conclusion? Hypophosphorus acid shows more reducing property, therefore, compared to orthophosphorus acid. Okay, that is the conclusion. Next, third one, orthophosphoric compound. Orthophosphoric. Now I am using IC, correct? So the reason of the using the suffix IC is in this compound phosphorus shows maximum oxidation state. And what is the formula? Now I think you get the thing. What may be the formula of the compound and all that, correct? It is H3PO4. H3PO4. Okay, H3PO4 is the formula. And now, what is the oxidation state of phosphorus in orthophosphoric? Oxidation state is -24. How much? 8. 3 goes out. So -8 plus 3. Yes, it is -5 goes to right side. Then you get +5 oxidation state. Here, oxidation state of phosphorus is maximum. Therefore, I am using IC. And the number of oxygen is more. Therefore, I am using ortho. So these two are the orthos, and this one is hypo. Because of the lower oxidation state of these two, I am using OUS. It is okay. That's a very simple things present in this type of naming of the compounds. But understanding the things is very important. Correct? If we completely understand the concept of writing the name of the compound, now writing the name, writing the compound, writing the structure, all things become now easy. Right? Please remember the use of the suffix and the prefixes of this compound, and all things become easy. Next, what is the structure of orthophosphoric acid? oxygen at the egg-shell position and with the double bond, and other all three tetrahedral bonds are with the OH. Yes, this is the structure. Just count the numbers. Phosphorus 1, oxygen 1, 2, 3, 4, 4 oxygen, 3 hydrogen, orthophosphorus, phosphoric compound. In the orthophosphoric compound, what is the oxidation state? +5 is the oxidation state. How many POH bonds? There are 3 POH bonds, and there is no pH bond. There is no pH bond. Does not show any reducing property, correct? Yes. Okay. So these are the things under the oxo acids of phosphorus. So these three are the very important oxo acids of the phosphorus. Except these three, there are other three oxo acids of phosphorus are there. Okay. Let us discuss the fourth one. Metaphosphoric acid. Metaphosphoric. This metaphosphoric, also known as polymetaphosphoric, also in a few cases, if they undergo polymeric chain, polymerization. So because of that, we use the word poly. Okay, polymetaphosphoric. Then phosphorus is in the center. Very easy to write the structure. Correct? Clearly observe the structure. O, again P contains O, again O, next P. Similarly, polymerization take place, and with one OH is there. OH, sorry, here is the OH. Look at the chain goes on. N number of. If we consider the only one monomeric chain, the compound formula is HPO3 N number. Only one for one monomeric structure. I'm using HPO3. HPO3. Oxygen again comes like that. So this is the polymeric chain of polymetaphosphoric acid. If we consider N is 3, then they undergo cyclization. Okay, cyclic phosphoric acids. Cyclic phosphoric acid. HPO3 3 number. Then it is cyclic. How it will become cyclic? Phosphorus like that. Oxygen which is there, oxygen which is there. O, each phosphorus contains one O, and each one contains OH. Like that. So this is the cyclic polymerization happens, and cyclic polymerization that leads to formation of cyclic phosphoric acid. Okay, so these are the different phosphoric acids of oxo acids of phosphorus. Okay, but these three are very important. Structure of these three are very important. Okay, please note it down for your exam. There is a possibility of asking the questions on the structure of this one. Okay, definitely 1 mark questions is asked based on the oxo acids of phosphorus. One structure very important. Let us discuss the few things under these compounds. Okay, how this one, first one, shows reducing property. I am simply saying it has more capacity of reducing nature. If AgNO3 react with dilute AgNO3 react with H3PO2, what may be the possible product? Possible product is it has capacity of reduce the any compound, reduce the AgNO3 into Ag plus that converted into H3PO4, H3PO4, and other thing is HNO3. Just balance the reaction. Try to balance the reaction. Hydrogen 3, 4, 3, 5 more number. Okay. Next nitrogen, one nitrogen, one nitrogen, one is number of oxygen 3, 1, 4. Just trial and error. Okay. 3, 1, 4 plus 2, 6, 4, 7. Okay. So to increase the number of oxygen, just I am increase the number of water. When I am increasing the number of water, then number of HNO3 increases. When number of HNO3 increases, AgNO3 get increases. Therefore, it becomes 4 AgNO3 to water 4 Ag. Now count the hydrogen. 2 into 2, 4, 4. Okay, plus 3. 4 plus 3 is 7. Next 3 plus 4, 7. Balance. Okay, so this is the balanced chemical equation of reducing nature. Okay, if in your exam, this is the possibility of asking the question also. Justify HPO2 is shows reducing property. Then we should write the equation. Next, the another very important concept under these oxides of phosphorus. Just additional thing for you. Number of, there is a possibility of asking the questions on these cases also. How many OH bond, how many pH bond, and all that. And based on that, what is the basicity of the compound? These are acid, correct? You are studying the little bit about the basicity and acidity in the first year. In case of acidity and basicity for acids, the question is asking for basicity. These are all acids. Therefore, there is a possibility of asking the questions on basicity of the compound. What is the basicity of hypophosphorus acid? What is the basicity of orthophosphorus acid? What is the basicity of this one? And all that. So, basicity is capacity to leave the hydrogen. So, just clearly observe the compounds, and in that cases, oxygen hydrogen bond, it is completely based on oxygen hydrogen bond, based on oxygen hydrogen bond, the answer is, our basicity is identified. You are well known about the basicity, just try it. Okay, it is just homework for you, it is just additional thing, and identify the basicity of the H3PO2. What is the basicity of H3PO3? What is the basicity of H3PO4? So homework for you, just determine the basicity of this compound and return your work in assignment. Okay, so these are the oxo acids of phosphorus. Next, move on to the next group. Okay, so this completes the 15 group elements. I think we are very lucky because there is no study of phosphine, there is no study of, in one way it is very lucky, and in another way you are bad luck. Okay. Why? You are not getting the knowledge of phosphine and the compounds of phosphine, phosphorus trichloride, phosphorus pentachloride. I think you lost all these things. But it eventually happens because of this pandemic. Okay. Now let's move on to the group 16th elements. Okay. Now, what are the elements present in the group 16th? Group 16th, it is also known as chalcogen. Chalcogens. The word it is derived because of the Greek word. There are several meanings there. Gens, just a production, produced or occurrence, based on occurrence. Like halogens, ocean occurrence. Okay, mainly the compounds of halogens is obtained from ocean. And similarly, the chalcogen is because of the occurrence or quantity or elements extracted from the extracted in which part of the earth. So mainly these elements, the group of 16 elements are oxygen, sulfur, selenium, tellurium and the polonium. These compounds are, or the elements are, these elements are combined with different compound and mainly observed in the earth crust. Abundance of the element is observed in the earth crust. Because of that, we call it as a chalcogen. And we know that oxygen and sulfur, these are the main ores of the different metal. So, or the metals are exist in the form of oxides and the sulfides. Because of that, we use the charcoal gels production. So, we separate, okay, or we extract or we obtain the compounds from the aqueous. Because of that, we use the word chalcogen. Okay. In this video, we will discuss the only electronic configuration, atomic number only, and other thing will be discussed in the next video. Okay. Oxygen, just I will write the number of electron or the atomic number of this compound: oxygen, sulfur, selenium, tellurium, and polonium. A similar way of the 15th group elements. So these are the 60th group elements. These 16th group elements are remember by using the another Bunny statement. The Bunny statement of this one is our sir cell telephone. Okay, you just remember the statement or sentence our sir cell telephone. So our sir, O oxygen, sir, sulfur, cell, selenium, tellurium, phone, polonium. Okay, so these are the elements present in the 16 group elements, and the atomic number. Okay, occurrence, you are well known about the occurrence of these compounds. I think oxygen is the most abundant element in the earth crust. It exists in the form of oxide, more than 46.6% by mass. Okay, 46.6% by mass. That much quantity of oxides obtained from the earth crust or exist in the earth crust, and around 20.95%, nearly equal to 21%, 20.95% by volume of oxygen is exist in our atmosphere. So therefore the oxygen is the most abundant in all these compared to all the elements of the 16th group. And the sulfur, it is very rare case, okay, 0.03% to 0.1% by mass exist in the earth crust. And this selenium, tellurium, these are radioactive elements. Mainly they are combined or they are present with uranium and all that. Okay, uranium and thorium. Polonium is again, it is a radioactive, little bit radioactive, more radioactive compared to this selenium and tellurium. Okay, polonium is also radioactive elements. So existence is lesser, very lesser volume compared to other. Okay. Now, what is the atomic number of these elements? Oxygen is 8, sulfur is 16. Using one trick in the 15th group elements, I think 8 plus 8, 34 plus how much? 18. Next 18, 52. Next 32, 84. Okay. So these are the atomic number. Just note it down the atomic number. Then writing the electronic configuration become very easy. I think electronic configuration of these elements. Electronic configuration. Before that, what is the electronic configuration of the common electronic configuration of the 16 group elements? The common electronic configuration is NS2. It is common for all p block elements, and P 13, 14, 15, so 16. Fourth group of the p block elements, therefore P4. NS2, NP4 is the common electronic configuration of 16 group elements. Okay. Now what is the electronic configuration of each one? Hydrogen is core with the helium the core, and the electronic configuration 1s2, now it becomes 2s2, 2p4, 2 to 4 plus 4, 8, atomic number is 8. Now satisfied, I think correct. Next, helium, neon, 3s2, 3p4, nice, helium, neon, argon, 3d time. Now b orbital entered to this element. 3d series completed or started here and completed in this case. So 3d10, 4s2, 4p4, helium, neon, argon, krypton, noble gas core. Next, 4d10, next 5s2, 5p4, helium, neon, argon, krypton, xenon. Last one, xenon. Okay, xenon is 4f14, 5d10, 6s2, 6p4. Okay, this is the electronic configuration of this element. So based on electronic configuration, we are studying about the circular size, ionization enthalpy, electronegativity, and electron gain enthalpy. Electron gain enthalpy play a role in this part. These all things are commonly called as atomic properties of the 16 group. That part will be discussed in the next video. I will stop here the electronic configuration of the 16 group elements. Please note it down all these electronic configuration, atomic number, work on this part. These all things are very important for your exam point of view also. Thank you for watching.